In this problem, a pitcher rotates her arm through 500 degrees starting from rest until the ball is released at 32 meters per second. We're asked to find the angular acceleration and the time it takes for the softball pitcher to release the ball. To solve this problem, we first need to know the angular velocity of the softball, which we found in the previous part, but is restated here and is equal to 40 radians per second. To solve for the angular acceleration and the duration of the pitch, we will need to be able to use rotational kinematic equations. The first step is to convert the 500 degrees through which the pitcher rotates her arm from degrees to radians. We want to do this in any calculation that is involving an angle. To convert from radians to degrees, we multiply by the conversion factor of pi radians is equal to 180 degrees. Doing so, we find that the pitcher's arm travels through 2.78 pi radians during the pitch. To find the angular acceleration, we want to use a kinematic equation which uses the quantities which we know the value of. These quantities are the initial and final angular velocities and the initial and final angles of the pitch. We therefore want to use this kinematic equation here. We can simplify and solve for the angular acceleration and arrive at this expression here. We then substitute in the known values and evaluate to find that the angular acceleration is 91.6 radians per second squared. To find the duration of the pitch, we want to use a kinematic equation involving time and any of the known quantities that are listed here. This kinematic equation will work because we know the final angular velocity, the initial angular velocity, and we just solved for the angular acceleration. Solving this equation for time and substituting in the values that we know, we find that the pitch lasted 0.437 seconds.